In the second video, we're going to continue just developing an understanding of what a polynomial is. So here is what you need to know. There's something called the degree. The degree of a polynomial is the sum of all the exponents of all its variables if you're dealing with a monomial. In a polynomial, it is the greatest degree of any term in the polynomial. So let's be clear about what the word term means. So let's just write 2x squared y plus y cubed. This is a term, and this is a term. So anything separated by addition or subtraction is a term. So because polynomials are made up of multiple terms, you'll have to find the degree of each term to determine the degree of the polynomial. This will be more clear with examples. Take a moment to write all of these down, throwing semicolons after them, so that afterwards we will list the degree of each polynomial. I'll start talking about these in a moment, so pause this and get this written. I think it's all clear enough too. Now this first one is a monomial. There's no addition or subtraction. So 5xy squared is just one single multiplied block, if I think of it that way. But I have to go to each variable and realize what the degree of each one is. So x has a power of 1, and y has a power of 2, so 1 plus 2 gives me 3. So the degree of this first one is 3 because each term, which is only made up of one term, totals up to 3 here. So 1 plus 2 is 3. Now in this next one, we have separate different chunks. So here's a term, and here's a term. Now what's strange is that this 5 here, you could think of it as 5x to the power of 0. So when there's no variables involved, the degree on this one is 0. Now you don't have to show this, but I'm drawing it in red so that it kind of stands out. There's only one variable in this term, so the degree of this term is 2. But there's 2 in this term, and 2 plus 2 gives me 4. I'm going to jump back to the definition for a moment. A monomial is the sum of the exponents and all its variables. So if this was just one term, it would be 3 because it would be a monomial. But since there are two separate terms in this one, it makes it a polynomial. So that's why we took 2 plus 2 to get 4, and then could kind of ignore these because we knew they were less. We didn't have to bother writing them. When I look at this one, the first term has a degree of 1. The second term has a degree of 2. The third term has a degree of 3. And the last one has a degree of 0. So for this polynomial, its degree will be 3. Make the final two OYO problems, and I'm going to resume talking about them, so pause it, because I'm talking about it now. Okay, I'm talking about this quickly. 1 and 5 gives me 6, and 1 gives me 7. I think the degree of this one's 7, unless I screwed something up. I see 5 here, 4 there, and they can't be combined, so we're going to go with 5 as the degree of this polynomial. Arrange polynomials in ascending order. Now if you were to climb a staircase, that is ascending. So if you're not sure about ascending versus descending, you might want to draw an arrow up, and then a downward heading arrow for descending. That's feeling wrong to me with the spelling. Google me. Correct me if I'm wrong. Okay, so ascending, descending, arrange the terms of each polynomial so that the powers of x are in ascending order. Now this is not what is normally the conventional way. The conventional way is to do descending, so we'll do that next. Alright, go ahead and write down the first example, 7x squared, 2x to the fourth minus 11. And if you look at these powers, these exponents, they're not in order. And since we're ascending, we have to remember that the degree of this term, since it doesn't have a variable, would be the lowest value. So we're going to put that one first. So we're going to write negative 11 first, then 2x to the fourth, because 4 is less than 7, plus 7x squared. I don't think you can mess these up unless you switch the vocab terms around. But the other thing you might do is you might just forget to put a minus where it belongs or a plus where it belongs. So keep an eye out for that. Since these were two steps, I'll skip a line. The next example I want you doing is 2xy cubed plus y squared plus 5x cubed minus 3x squared y. Okay, if you want to, you can maybe lightly write this in pencil, because this is a little bit of a working memory thing. You know, this first one's 4, so maybe you note that somewhere out of the way, though, so that you don't think it's an exponent. You can lightly circle the 2, you can lightly circle the 3, and then you can think of this as being 3 as well. So of all these different terms, which one's the lowest? Well, the lowest one is this y squared value, so I'm going to write that one at the very start. Now I have a bit of a tie. This term and this term both are of the third degree. Don't overthink it. Either way is really fine. So we'll just write minus 3x squared y plus 5x cubed. And then the last of the terms I'll write is going to be 2x y cubed. Now, since nothing was combined in this and we can't combine anything here, make sure that you're good. You have like 1, 2, 3, 4 terms. You should have another 4 terms show up. Now we're going to arrange these in descending order. And let me tell you this. Descending order is the more common way. And I'm not sure that I have this broken apart in your notes. So maybe put the word descending after skipping a line, and then show a little line underneath it so it looks like a heading. And then let's write 6x squared plus 5 minus 8x minus 2x cubed. And when I look at this, I see only x's, so maybe pretty quickly you're like, well, negative 2x cubed plus 6x squared minus 8x plus 5. Box it. You're done. Star this, and then put a note by it. More conventional. This is the most conventional way to do it, is in descending order, starting alphabetically. This chapter is purely focused on getting you familiar with what a polynomial is compared to a monomial. And once you're there, you're good to move on to the next section.